Chapter 5, Holiday and Resnick, Problem 6. In a two-dimensional tug of war, Alex, Betty, and Charles pull horizontally on an automobile tire at the angles shown in the overhead view of this figure. The tire remains stationary in spite of the three pulls. Alex pulls with force FA of magnitude 220 newtons, and Charles pulls with force FC of magnitude 170 newtons. Note that the direction of FC is given. What is the magnitude of Betty's force? This is Betty, Charles, and Alex. Now I've set up a force table to illustrate how this problem is the same as your lab problem, but with different angles and different newtons. So we have Alex, and this will represent Alex. We have Charles. This will represent Charles. And we also have Betty. This will represent Betty. So I put the weights that represents the amount of newtons that each are pulling. And also, I've already calculated the angles that Alex and Charles are pulling with reference to this 90, and 270. Use that as my x-axis. So y would be these axes. And I have Betty at 180. So we're just going to balance this out by adding weights, and then I'll actually work the problem. So we'll add, I already have a 20-gram weight, so I'm going to add a 5-gram. Moves a little toward the center. Now I'm going to add a 2-gram. Moves a little toward the center. Now I'm going to add a
1 gram.
1 gram. And that totals the 29 grams that we've added to balance this ring in the center. So we will actually work this problem out analytically in a second. So from the force table, now we're going to work the mathematical solution to this problem. First, you know that the sum of forces in the y is going to equal F Alex in the y plus F Charles in the y plus F Betty in the y, and that's going to equal MA. Since the ring does not move and is static, the acceleration is 0. So we know FA in the y plus FC in the y, Charles, is going to equal to minus F Betty in the y. Also the sum of forces in the x direction is F Allen in the x plus F Charles in the x plus F Betty in the x equal MA. It does not move because the tire is static. It doesn't move, so we have no acceleration. So in the x, we have F.A. Allen in the x plus F. Charles in the x equals minus F. Betty in the x. So we're going to let Betty be along the 180 axis here on our Cartesian plot. But we don't know her magnitude. But we do know that 137 minus 90 is going to give us 47 degrees. And that's Alex's angle with the x-axis. And we also know that Alex is pulling at a force of 220 newtons, which allows us to figure out the I component and the x component of this triangle. And 220 times the sine of 47 degrees is equal to 160.90 degrees. And 220 times the cosine of 47 degrees is equal to one, I shouldn't say degrees, that's newtons. 160.90 newtons is equal to 150 newtons. So we know this is equal 150 newtons. So also this side has to equal 150 newtons. We know that because the tire doesn't move in the x direction, it's static. So this side of the force must equal this side of the force. We also know that Charles is pulling at a force of 170 newtons. This will allow us to figure out what theta is. And so we can figure out theta. We can say theta is equal to cosine inverse of 150 divided by 170, which equals 28.1 degrees. So we can get, now since we know that's 28.1 degrees, theta, we can get this vector here. We can get And this would be 170 times the sine of 28 degrees, which is going to equal 28. It's going to equal to 80.1 newtons. The problem is solved. We're adding these vectors, which is in the j hat direction, and the sum of these two vectors is going to equal what Betty is pulling, because she is the counterforce to these two vectors here. So when we look at this, the sum, we got F of Alex, which is 160.9, and we have F of Charles, which is equal to 80. So when we add those two together, we're going to get $241 newtons. That's the force that Betty is pulling in at an angle of 180 degrees. Okay, on my force table, I got a force for Betty of 284 newtons. And if I wanted the percent difference, I would do 284 minus 241 is percent would be 43 times 100 equals 15% difference from the force table to what the actual math is showing me. Of course, the force table, some people get better results, but I got a 15% difference.